Okay, there we go. All right, I've got several things going on at once, so I hope sometimes my QuickTime player kind of fades out. But here's the first problem out of this list. All right, it says a 22.8 kilogram bullet. All right, so it's 22.8 times 10 to the negative 3 kilograms. It's fired from a rifle, and it takes 3.72 times 10 to the negative 3 seconds for the bullet to travel the length of the barrel, and it exits the barrel with a speed of 753 meters. Assuming that the acceleration of the bullet is constant, find the net force exerted on the bullet by the gases in the gun, all right, or in the rifle in this case. This is my rifle, this is my gun, this is for fighting. Anyway, all right, so, well, what do we have here? So in problem 71, what do we have here? We've got here we go. Got the mass of the bullet, all right? And so you got the mass of the bullet. You've got the time, and you got the final velocity. And you want to find the force. Here's the bullet. It's being pushed. And you have the initial velocity, which is equal to 0. All right, so the sum of and we're going to assume it's going in the x direction. So the sum of the forces in the x direction is equal to mass times acceleration, which is equal to F, which is equal to the forces by the gas, I guess, was what we're trying to solve for. What do you need? You need the acceleration. Hey, if you've got a time, you got these two guys, can you find an acceleration? Think so. All right, well, that one was kind of easy. Let's go on to the next one. I'm not going to do them all. I'm just going to do a hint. Okay, I love this problem because this is a little like the elevator problem that we did at the end there. So this is problem 72. Now think about this. This is a fun problem. I really, really like this problem. All right, because this is a fisherman is fishing from a bridge and using a 31 Newton test line. In other words, the line will sustain a maximum force of 31 newtons without breaking. All right. So what is the weight of the heaviest fish that can be pulled up vertically when the line is reeled in at a constant speed? This is why you don't jerk. You let them take the line, because we're probably going to find out that the answer to A is less than the answer to B. Or if you're trying to pull that fish in with an acceleration of 2.98 meters per second. All right. So we've got mg on the fish. Okay. What is the heaviest fish that can be? So we want to find the heaviest fish. Now, we're discounting a lot of stuff here. We are discounting all kinds of stuff because there's a thing called, you've learned about the frictional force. What do we call the frictional force when we're in water? Frictional force when we're in water is called drag. There's a lot of drag here. I don't know if any of you have ever gone fishing for bluegill or crappie even. They're a lot of fun to catch because those little suckers turn their body sideways in the water and create a lot of drag when you hook them. And you think you got like a 2-pound bass on there, and you got a 3/4 pound crappie, which is a nice size crappie, but still. Anyway, so let's look at A here. All right, let's just look at A. So a fisherman is fishing from a bridge and is using a 31 Newton test line. So the maximum force that will break that is that will snap it is 31 newtons. So here we go. So let's draw the picture. All right, so I've got this. Here is the fish on the hook. It's got an mg. It's got a tension going up this way. If T exceeds 31, this thing's going to bust. All right, so we got a tension going up this way, and we got a fish going that way. All right, so if I'm pulling this up, if I've got an acceleration, so here we go. So we're going to take a look at the sum of the forces in the y direction is equal to the mass of the fish times the acceleration upward, which is equal to the tension minus mg. This is just like the elevator problem then, isn't it? Okay. So look at this. mf times a plus mf times g is equal to the tension. Whoa! And they give you what the tension is, and you solve for m. Well, but what happens if constant velocity? Y'all are pretty good at this. Part B, constant velocity means the acceleration